Let's use a small dataset to show the difference between Quartile.INC and Quartile.EXC, inclusive and exclusive. First, let's set the data size is odd number. So here we have total 9 numbers. Now let's get the 5 numbers by the .inc function equals Quartile.inc. Then we choose this data set and we log the data, press F4. Then you see add the dollar sign and a comma, 0, 1, 2, 3, 4 means 5 numbers. So we press 0, we get the minimum, and we just drag down, use the autofill. And then the second one, Q1, is we change the number to 1. Medium is Q2, change it to Q3, change 3. Maximum, change it to 4. So we get 5 numbers. Now let's do them manually to see what algorithm used by Excel. And here we already make the dataset in order from the minimum to maximum, or you can decrease in order maximum to minimum. Then you see the minimum is just the first number, the last number is 90, and the medium is right in the middle because we have the size is 9. So the 30 is medium. 4 numbers in front of 30 and 4 numbers behind the 30. And what's the Q1? Here for the .inc, Excel split the dataset, each half includes the median. 5 data's odd number. So then the right in the middle is 28, 2 numbers before and 2 numbers after. So this is the Q1, 28. And another half, 31, is right in the middle. So that's the Q3, 31. We know this algorithm. And now let's see the .exe. We know .exe only for Q1, Q2, Q3, not for minimum. So we still minimum, we just manually input is 23 because we already line up in the increasing order. So last number is maximum, 90. And the Q1 is Quartile.exe. Then the data set and the F4 logs the data, comma. Then you press 1 means Q1. Then we could just drag it down. The Q2 simply change the number is 2. And Q3, this is 3. 5 numbers. And let's do them manually to show the algorithm. So clearly minimum, just copy. Here is the same. For the medium, still solid 30 because 30 right in the middle. This is odd data size. Exclusive.exe splits the dataset into 2 parts. Each half doesn't include the median. So we have the first 4 numbers. So Q1 should be 24 plus 28 divided by 2. So is 24 plus 28 divided by 2. It is 26. And Q3 is 31 plus 33. We know is 64, then divided by 232. So now we verify the algorithms because n is odd. This is very easy to manually figure out the algorithms in the Excel. And now we go to this even data size. And this is the hard part. It's very complicated. Now let's set the data size is even. So we choose 8 numbers. So by .inc, click this function and choose the data set and log the data F4, comma, and 0, and drag it down. There is 1 for Q1, medium is 2, Q2, Q3 is here is change number to 3, maximum change 4. So we get 5 numbers. Let's show the algorithm. We only verify Q1, Q2, Q3 because we know minimum is just solid 23, maximum is 90. First, we need to get to the interval. Interval equals, here we have data size 8, So 8 minus 1 is 7. 7 times 0.25 and plus 1. This is equals 2.75. Here we get the interval. That means the Q1 happens to between this second number and the third number. So 24 and 28. The distance, a quarter distance is 28 minus 24 times 0.25, a quarter. So here is, we say just 4 times 1/4, so it's 1. Now what's the Q1? Q1 is second number, 24, then plus 3 times a quarter distance, or equals the third number, 28, because 23 minus a quarter distance go to 2.75. So 28 minus a quarter distance. If we just choose this, the first one, so 24 plus 3 times a quarter distance is just 1. So we get a 27. You see this 27 and this 27 match. Let's do the Q3 times 0.75, then plus 1. So what's the answer? I just simply change here. So equals 7 times 0.75 plus 1. So interval is 6 to 5. The Q3 happens between 6 and the 7th number. So 1, 2, 3, 4, 5, 6. 6th number and the 7th number. From the 6th plus 0.25. So a quarter distance from the 7th number is minus 3 quarter distance. So here this distance I just change here is minus 30, and let's calculate, is equals 1 times a quarter, so 0.25. And now Q3 here is, I mark it here, so from the 6th number, so should plus a quarter distance. So is 30 plus a quarter distance is 0.25. Or they want the 7th data, then minus 3 quarter distance is 0.25 times 0.25. So we get the answer is, if we just plus for this one, so 30.25. And for the medium is simple. Medium is 30 plus 29 is 59. 59 divided by 2 is 29.5. Now let's see .EXC. Now .EXC only give you Q1, Q2, Q3. So minimum still the first number, because we line up the last number is maximum. And the Q1 is Quartile.INC, and we choose a data set, and F4 lock it, and 1. 1 is Q1. And then we drag it down. So the second medium we just choose 2, Q3, choose 3. So we get this Q1, Q2, Q3. Now we also manually verify those 3 numbers. And simply the medium, we know we have even size data set. This middle 2 numbers divided by 2. It simply is 29 plus 30, 59 divided by 2. So we verified is 29.5. Now for the Q1. Q1, here the interval is 8 plus 1, so it's 9. 9 times, because for the Q1 is 25 percentile, so times 0.25. So because we already added 1 here, this is for Q1, the interval. For Q3, then is 9 times, because Q3 is 75 percentile, so times 0.75. And let's do the Q1 first. So 9 times 0.25 equals 2.25. That means for Q1 happened to second number and the third number. From the second number plus a quarter distance. From the third you need minus 3, need minus 0.75, so 3/4 distance. What's the distance? This distance is 28 minus 24 times a quarter. So 28 minus 24 is 4. 4 times 0.25 is 1. Here Q1 is from the second number, so it's 24. 24 plus a quarter distance, so just plus 1 equal 25. We could copy here. Or is 28 minus 3 is 25. So we verified Q1 is 25. Now let's see the Q3. Q3, 9 times 0.75, so 9 times 0.75 is 6.75. That means the Q3 happens between the 6th number and 7th number. From the 6th, you need to add a 3/4 distance. From 7th, you need to minus a quarter distance. Now let's see what's the distance. This distance should be the 7th number, 31 minus 30 is 1. 1 times a quarter, so is 0.25. Now Q3 is from the 30 plus 3 times quarter is 0.25. So we know it is 37.5, right? 37.5. Or you could from the 7th number is 31, only minus 1/4 distance, so minus 0.25. So still we get a 30.75. Now we know once the data size is odd, then the algorithm goes very simple. But if the data size is even, here we have 8 numbers, then the algorithm are kind of complicated. I hope by this simple data sets, you could understand the algorithms for the .INC inclusive and .EXC inclusive functions in Excel.